Hey everyone, and welcome to Star Studies. My name is Parker Holzer, and in this video series I'll be explaining the research that I did as an undergraduate student in my good old days at the University of Utah. And while I was a student there, I joined an astronomy research group that was led by Professor Ines Evans. And it was in this research group when I got to do all of the research that I'll be telling you about in this video series. I primarily created this video series because a lot of my family members and friends were very interested to know what I'd been working on, but they just couldn't understand it from all the vocabulary that was involved, all the physics that was involved. It was just way over their head. So in this series, I decided to explain all the background knowledge necessary to understand my research, plus, of course, I'll be giving some of the results that I got in my research. And I'll be doing it in a way so that pretty much anyone would be able to understand it, no matter what your background is. So, may the force be with you. So, this first episode is all about clusters of stars. So, when you look at this image right here, or when you look up at the night sky in the middle of the night, you can see a lot of stars. At least as long as there's not too many clouds or sources of light pollution or something like that around. Some of these stars look brighter than others. Some might look a bit more blue or white or red if you look close enough, actually. Some even look like they're in groups of stars with others in the sky, while others just seem to be isolated all on their own. And by using telescopes and zooming in on these stars in the sky, some of these twinkling objects turn out to not be stars at all, actually. Some of them are the planets in our solar system, reflecting light from the sun, like, as shown here, Jupiter and Venus. They look like stars, but they're actually the planets in our solar system. And they're actually pretty bright compared to most stars out there. Others of them are actually faraway galaxies, producing their own light, but because they're so far away, they appear as if they're a star. Like as is shown here, the Andromeda galaxy that you've probably heard of is really small, but we can see that as we zoom in on it, it of course looks like a galaxy. Some of them are either planetary nebula or supernovae, the remnants of stars that have long since died away. And you can see here, as we zoom in on this object, it turns out to not be a star, but a planetary nebula. It happens to be the very famous Eskimo Nebula. And still others of these twinkling objects are actually large groups of stars, called clusters. And what you're looking at right now is NGC 104. You can see as we zoom in a little bit on it that it, of course, is a whole group of stars and not just one. And it's about star clusters that I'll be talking about for the rest of this episode, and it's actually the type of object in the sky that I used for pretty much all of my research. So, there are mainly two types of star clusters that we find in astronomy. Globular clusters, which one is shown here on the left, and open clusters, one is shown here on the right. Open clusters usually contain about 200 to about 300 stars, and sometimes they even have fewer than 200. And they're held together very loosely by gravity, and it's actually not unexpected for a large number of the stars to eventually drift away from the whole cluster. Globular clusters, however, can have up to thousands of stars in them, and some even have tens of thousands in them. Because there are so many more stars in a globular cluster, they are very tightly bound to each other through gravity. And you can usually see that characteristic in most pictures of globular clusters, because they appear very much like a ball of stars. Another consequence of having so many more stars in globular clusters than open clusters is how it's much harder to zoom in on a single star without having other stars right next to it. And I'll explain later on in a future episode of why that can actually be problematic for the type of research that I've been doing. But overall, You can think of a cluster of stars as a swarm of bees flying through space together. Pretty much all of my research has been focused on the open cluster M67, and that's shown here. It really hasn't been given any other name that isn't also some code, so oh well, we're stuck with it. But why would someone want to study the stars in an open cluster? Well, overall, because open clusters provide an ideal way to study how stars evolve over time. And I'll explain in a future episode why that is the case. And the overall idea is because the stars that belong to an open cluster have many characteristics in common with one another. And here are some examples of some of these similarities the stars share. Stars in an open cluster are approximately at the same location in the sky. That's pretty obvious, otherwise they wouldn't be a cluster of stars. Also, since the whole cluster is traveling together through space, they all share a very similar speed and direction of travel. And I'll explain why this is important, particularly in a future episode as well. Here's another picture of a different open cluster. Another similarity that stars in an open cluster have, or at least are expected to have, is their age. And this is simply a consequence of how open clusters form. This cluster that you're looking at right now is a very young cluster in the process of forming. Many studies indicate that since open clusters form from these huge clouds of gas left over from stars that have completely died, the stars in an open cluster, well, should be expected to share a very similar age because they would have been born around the same time as each other. Additionally, since they were born from the same big cloud of gas, the stars are also expected to be made up of the same amount of each element in the periodic table. And I'll explain why each of these similarities was particularly important for my research in the upcoming episodes. But overall, these similarities make it easier to do the research. And kind of an analogy of what might make it a little easier to understand that is it's kind of like if you're a business owner and you have a problem that you need to fix, but there are 20 or so different things that might be causing that problem. If you're able to find a way to research the problem that pretty much eliminates 10 of those 20 variables, then it's much easier to get to the core of the problem. And that's the same idea here. So, here's that picture of M67 again. I mentioned that I've been studying the open cluster called Messier 67, or just M67. It's named after Charles Messier, who originally gave it that name. But why out of all open clusters in our galaxy did I choose M67? Well, for a number of really valuable reasons. The first reason is because it's relatively close to our solar system, at least when compared to other open clusters. It's still way too far away to even think about getting to it in a lifetime, but it's one of the closest open clusters to us. And this is valuable because it means that we're able to obtain much more reliable and detailed data of its stars. It also has the consequence of being very well known to astronomers. Enough so that it's probably one of the most studied clusters in the night sky. So a lot is already known about this cluster from previous studies. And this is all simply a fact of how it's relatively close to our solar system. The second reason for kind of choosing M67 is because it's very famous for being full of stars very similar to our own sun, actually. As a matter of fact, for a while, astronomers thought that the sun was actually born in M67 and just drifted away from it over time. But recent studies show that it's actually very unlikely that that's the case. But nevertheless, the stars in M67 have many similarities to the sun, such as their age, their chemical composition, and a few other things as well. And since the sun, out of all stars in the sky, has been studied for literally thousands of years by humans, we are very familiar with it. So, Of course, if you're familiar with something, you might as well study things that are at least similar to that. It's a much safer way to do your studying. And it's a much better idea than going off into a foreign land and trying to draw conclusions about that before you know hardly anything about that foreign land. And so these are the main reasons why M67 is the open cluster that I decided to study. So thank you all so much for watching Star Studies Episode 1 about star clusters. I hope you find it as interesting as I do. May the Force be with you, and I will see you next time on Star Studies.